Good morning students, myself Dr. Shantini Bhattacharya, Assistant Professor of EC Department, SRM Institute of Science and Technology, Katankulasi, Chennai. Today I am going to start a new topic of digital logic design is programmable array logic. Okay. So, what is programmable array logic? It is actually commonly used programmable logic device which is known as PLD, and it has a programmable AND array and a fixed OR array. This is actually the diagram. Okay, programmable AND array. Here AND array is actually programmable and there is a OR part is actually fixed. Because only AND array is programmable, it is easier to use but less flexible than the programmable logic array. PLA we will discuss in the next video. So keep watching my all videos, it will be helpful. So now first of all, here important part, you have to know the design procedure, how to design basically a PAL. Okay, so a combinational circuit is defined by a function x. This is the minterm summation of m 2 3 6 7, y equals to summation of m 0 2 3 5, z is equal to summation of m 1 6 7. Okay, so now you have to implement the circuit using PL, which consists of 3 inputs. Okay, so A, B, C, these are the 3 inputs and 3 outputs are there, X, Y, Z. X, Y, Z are the 3 outputs and A, B, C are the 3 inputs, and there is a 3 inputs, all of you know, there is a basically a 8 combinations are there from 000 to 111 and 3 outputs X, Y, Z. So these are basically 2, 3, 6, 7 are basically nothing but in the truth table you can see wherever in the output X, wherever the 1 is there, it is only mentioned. It is actually 0, 1, 0 means 2. Here 1 is mentioned, so it is 2. Here 3. Here basically 6, it is 7. In this way y and z also. Basically 2 types of question may come. First of all, this type of truth table they can provide, examiner can provide, and from this truth table you have to find out the what is x, this type of thing you have to write, or directly they can give you this type of question. You have to you have to design the PAL. Okay. So I have given both the option so you can understand more. Okay. Now what is the step 2? Okay. So for this purpose, first of all, based on these expression, we have to find out the value of x, y, z by using a K-map. Okay. So this is actually the K-map. This is actually 3, as it is a 3 input, so 8 basically cells will be there. I hope all of you know the K-maps basically basic things. So if you don't know, you just go through my Karno maps videos. It will be very much helpful to all of you to understand this problem. So now by using this basically 2, 3, that means in the K-map, first of all we have to, this is a 3 input, so 8 cells are there and we have to put 1 whatever the mean terms are given, 2, 3, 6 position we have to place the 1, and based on the Karno map principle there is a form basically quad, so from there the x is equals to b. So I am not explaining the Karno map again, just this is my request, go to the Karno map video, you can explain, you can your understand, you will actually better you can understand. Okay, so now similarly y also in the position of 0, 2, 3, 5 there are y there, so this 1 and 1 will make a pair, and this one will make another pair, and this is a single one is there. In this way this is the final y, that means a bar b plus a bar c bar plus a b bar c. Now similarly z we have to also find that a b plus a bar b bar c. Now we have to basically design the circuit. This is the step 3. So this is actually the circuit. So what is this? This is basically a buffer. Okay, this is basically a buffer, nothing but this is basically a buffer. So here this is the A, okay, and this line is basically A, okay, and this is basically a knot, okay. So this line is going to A bar, okay, and here also B, this is also a buffer, this line is contains for B, and this is actually the knot, this line is goes for B bar. Similarly, this is C, this line is basically C, and this knot line is basically C bar. Okay, now we have to find out how many number of AND gate we will use. You can see that in the case of X, there is only one expression B, but in the case of Y, there are basically 3 mean terms are there, okay, and in the case of Z, only 2 mean terms, okay. So we have to actually choose the maximum value of the mean term. So here we will choose 3 AND gates for per output, okay. So here also for X also we have to, whatever, as there is a only output B, but still we have to, for X also we have to consider 3 AND gate, for Y definitely there is a 3 AND gate, and Z also we have to consider 3 AND gates, okay, because there is a maximum number of AND gate. What is AND gate here? This is 3. If it is 2, then it if Y will be 2, then there will be a 2 AND gate, but as there is a 3 mean terms are there, so there are basically 3 AND gates are basically required, okay. So for X we have designed, this is 1 2 3 AND gate, this is for Y, 1 2 3, and this is for Z, last 3 are for Z, this, okay. So total 9 AND gates are there, for X 3, for Y 3, and for Z also 3, total 9. So 1 2 3 4 5 6 7 8 9, okay. Now how to design this actually, okay. So first of all, there is a X is equals to B, okay. So here we will, these are the basically output of the AND gates, and from there each line you have to connect this type of line. This is actually the OR gate, okay. Now these dots you have to make, okay. So here first of all, this is X output, this is Y, this is Z. For X output you can see only here I only make a dot, okay, and also here and also here, but these and these are nothing, okay. So it is basically a 0 output, okay. So only B and these outputs are connected to this OR gate. So X is equals to B. Now in the fourth AND gate, here this is A bar B, this is basically A bar B, this is A bar C bar, this is A bar C bar, and then A B bar C, this is A B bar C. These 3 dots we have to make. We will not make any dots here, because if we make any dots here, that means there is a connection. But as we make a dot here, here and here, so that means these AND gates outputs are basically going to this OR gate, okay. So Y is actually A bar B plus A bar C bar plus A B bar C. Now finally Z is actually AB plus A bar B bar C. So this is actually AND gate output AB. So this is A bar B bar C, and last part is actually nothing. So we can consider as 0, or you can say fuse intact, okay. That means wherever the AND gate output is 0, you can say fuse intact, okay. So here is basically, this is actually these points, okay. this point, this point, this point. We do not connect any point here, here. Okay, and also these cross points is actually, this is the B. This is actually, I have already told, this line is for B, so you have to make a connection here first. Okay, so this is actually the B connection. Here no connection, so nothing. Here is also no connection, nothing. Here A bar B means this line is A bar. We make a cross sign here, and B, this is, we make a cross sign here. Then then A bar C bar. So this is A bar, this is C bar. So in this position we make a cross sign. Then also this line, this is actually A, then this is B bar, and this is C. So this is A, B bar, C. In this way we actually design full circuits. Okay, so hope all of you can understand the basic design. These are the advantage of PL: highly efficient, low production cost compared to PLA, highly secure, highly reliability, low power is required, more flexible. And disadvantage: limited flexibility. Once programmed, the configuration of an array cannot be altered, and also propagation delay is also there. So these are the disadvantage and advantage. And now these are the application: digital signal processing, control system, embedded system, and also the communication system. Thank you so much. Keep watching. If you have any doubt, then give me a doubt this in the comment section. I'll try to solve this. Thank you so much.